Welcome back, everybody. I'm Chris, a retired fiber splicer. This is going to be the fourth video in the playlist series OSP fiber optics, and we're going to be talking about reading prints and understanding the fiber counts. So everything in blue marker is the neighborhood streets or the homes. Everything in black ink is the fiber routes, the cabling, the splice points, the counts of the cables and stuff like that. So what we're dealing with here is a new neighborhood. This neighborhood has 4 new homes in it. And this job would be like they're pulling drop type cables from the new home to the splice point. It could be in a hand hole. It could be in a splice case that you can get in your trailer. It could be within a splice ped. You'll have to, what job specific, but nonetheless, the theory behind this is going to be the same. We've got our distribution cabinet up here where our service comes from. It could be a feeder ped. It could be a cabinet. It could be a remote, wherever the light is coming from that powers the service up to these homes. In this particular situation, we're leaving our distribution cabinet and our CO cable is a 144. All 144 fibers on this are going to be able to be active. So there'll be a 144 count panel within this remote or this distribution cabinet for us to plug our jumpers into and test. Also for the telephone company to plug their jumpers into and actually emit the service to these homes. So we've got 2 field side mainline cables. They're labeled. A is our CO cable. All right, our field side main lines are the B and C cables here. Now, let's take a minute to look at this, the way that this particular telephone company and engineering firm has designed this job. They're starting with the last fibers first. And we know that because our A, B, and C fiber counts are written off to wherever I wrote them. I'm blind, so I can't exactly see it that well, but our drops, the 4 fibers, the small cables that go to the home from the splice point are labeled in numbers over here. So we can see over here that they've got the first 3 fibers laying dark or dead, however you want to word it. And then the last fiber of that 4 fiber drop cable going to the home is the one that they're wanting you to splice the service to. That also correlates with the main line, the 224 count cables. They're starting with the last 2 buffer tubes of this 144 at the CO splice. So at this first splice point up here, where the tap comes off the field cable that goes east there, and the field cable that goes south, we're pushing fibers 121 to 132, which is the rose buffer tube or the 11th buffer tube, however the cable is made. We're pushing those 121 to 132 fibers straight through into the end of the 24 count cable that's going south here. So the first 12 fibers of that cable will be dead or dark. And then 121 to 132 are going to splice into the orange buffer tube heading south from our first splice point here where that tap goes east. Now the eastbound field side cable here, our tap, is dead 1 to 12. The FC9 count that this panel is at this feeder distribution cabinet, 133 to 144, so that's the aqua buffer tube. So the last 12 fibers in that 144 count cable coming from this distribution are going to go east in the last buffer tube of that 24 count fiber. The rows or the second to the last buffer tube out of our CO side cable are going to continue southbound in the end of that 24 count cable, the orange buffer tube. All right, now that we've got that spliced, we're at the splice points that have the actual drops that go to the homes in them. I highly suggest you double check to make sure that the drops are labeled correctly. And if they are not labeled, there's two ways to go about identifying them, other than trying to tug on them. But to avoid tugging on stuff, we can look at the footages on those cables, okay? We can start at the splice point location, and let's say it's in a handhole. We can look at the footage, and let's say it says 1,001 feet. And then go to the next mark down on it. And if it says 1,000 feet, then we know that the count is going down from the splice point towards the home. So we estimate 200 feet or so. We go to the home. If there's one that says 840, then we look a couple more feet down the cable and it says 842, then we know we've got our sequentials, our footages on the cable are starting at a high number and going down towards the home. And at the home, we're starting at a lower number and going up. That's a way to verify it, but the best way to verify it is to put a red light on it at the home, go back to the handhole and look at the cables and see which one's got a light on it, then label it. Then there's no mistaking it. But a lot of times we're not splicing the part at the home, so there's not a connector or no real ability to put any kind of light on it unless we've got some fancy stuff to hook to a bare fiber end or put a mechanical splice on it or something like that. But so using your footages, paying real close attention, or using a red light, that's the only real two ways to go about doing that. Okay, so now that we're at this splice point here where the drops that go to the homes are, remember we're at the end, we're starting at the end with everything here. That's how they've got this job engineered. So when we open up these three cables, we've got our 24 fiber. Now it's at this splice point here, it's our CO side 144. It's leaving as a field side cable. Then we get down here, this field side has now become our CO side. So what we're going to do is we're going to take the last buffer tube in that field, that 24 fiber cable, them two drops that go to them homes that we've got labeled correctly so we identify which home they go to. We're going to take the rose and aqua fibers out of that orange buffer tube and splice them to the correct brown fibers of those 2 4-fiber drops, because the first 3 fibers are all dead in all 4 of these drops that go to these 4 homes. Does that make any sense? So at this splice point here, in our splice tray or whatever we've got, however it's engineered, whatever we're building, we've got the orange buffer tube opened up. We've got the 2 buffer tubes from them 4-fiber drops opened up. We've got both brown fibers out of each drop on our countertop or our table. And we've got the rose and aqua fibers out of that orange tube, and we're splicing to it. No different than when we get over here at the end of this leg. Remember, we're using the orange buffer tube coming from this main splice up here. Although the fibers are 133 to 144, we're still going to identify those 2 drops. We're going to open up our main, now it's our CO side. It left here is the field, now it's our CO. We're going to open up that orange buffer tube, them 2 buffer tubes from them 2 4-fiber drops, do the same thing. We're going to get both brown fibers out there, break out the rose and aqua fiber out of that orange buffer tube, and splice them to the correct drop going to the correct house. I know that shit sounds like Chinese, but that's in a nutshell how you would read a print. And I just drew this up off the top of my head. They get so much more elaborate than this, especially if you're already filled full of houses, you know, door to door, and you got a pet at every yard and you're looping cables through each one. But like I said, the measuring twice and cutting once thing is critical. So I'll do my best to get this video edited up and put up for you guys. If I can be of any assistance to you guys out there, or anybody needs help reading prints or figuring out what needs to get spliced to what, by all means, I'll put my email right here. Shoot me an email, I'll reach out to you, and we can build a relationship from there. See y'all.